Nuclear power. Nuclear energy is released when the nuclei of atoms are either split apart, nuclear fission, or fused together, nuclear fusion. A nuclear power plant harnesses the energy released from fission to generate electricity. Nuclear fission. Nuclear power plants are fueled by radioactive elements such as uranium. When atoms of the fuel are split, a huge amount of energy is released as heat. This heat turns steam-driven turbines, which power electricity generators. Nuclear fission uses small amounts of fuel and produces far less greenhouse gas emissions than fossil fuels. Inside a nuclear reactor. Nuclear fission takes place in a reactor encased in a strong, reinforced concrete dome designed to contain the radiation emitted. Let's explore the 6 components or phases of nuclear fission. Uranium fuel rods. Hundreds of metal rods grouped into bundles contain small pellets of uranium fuel. They are lowered into the reactor's core. Chain reactions. Unstable uranium nuclei break down, releasing heat and emitting neutrons. These collide with other nuclei, creating a chain reaction that provides huge amounts of energy. This process is also known as splitting atoms. Control rods. Control rods modify the speed of the chain reaction. When lowered in among the fuel rods, they absorb many of the free neutrons to slow down the reaction. Creating steam. Heated by the reactor core, the water flows into a heat exchanger, giving up its energy to a second closed system of piping that carries cold water. The cold water is turned into hot steam, under high pressure. Turning the turbine. Housed in a turbine hall, the turbine's fan blades are turned by the high-pressure steam from the heat exchanger. The turbines typically spin at speeds of 1,800 to 3,600 revolutions per minute. Power supply. The electricity generator is driven by the turbine's driveshaft. A transformer increases the electricity's voltage so that it can be carried by a local or regional power grid efficiently. Nuclear power station. A nuclear power station is made up of a nuclear reactor, steam-driven turbines, and electricity generators, all connected via numerous control and safety systems. Nuclear meltdown. The failure of a nuclear reactor's coolant system can lead to excessive amounts of heat building up in the fuel rods. In extreme cases, the rods can melt and burn through their containment structure. This can release huge amounts of radioactivity that may contaminate the environment. In 2011, following an earthquake and tsunami, 3 of the reactors in Japan's Fukushima Daiichi plant suffered partial meltdowns. Radioactive waste disposal. A 1,000 megawatt nuclear plant produces about 30 tons of spent nuclear fuel a year. Used, or spent, fuel rods are removed from a reactor every 2 to 5 years but still generate heat for decades and emit harmful levels of radioactivity for even longer. Most are initially stored in deep, cold water storage pools for a number of years before they are either reprocessed or placed in concrete-encased casks. Several countries have proposed plans to store waste deep underground, but no sites are yet operational. Geological repository plans. One proposed solution for radioactive waste disposal involves the already established technique of vitrification followed by burial in temperature-regulated deep boreholes. So there you have it. That's how nuclear power is created, stored, and disposed of. We hope you learned something new. If you like the video, please like, comment, subscribe and share with someone you know. Thanks for watching. We'll see you in the next video.